The objective of this video is to do an example of a strip footing. We're going to be finding the immediate and final settlement. For this video, we're looking at a point or a line inside the strip footing. I'll show you what that means in a second. To do this example, we have to find B on H or H on B. We then, given the Poisson's ratio, we'll find the I value using a graph like this, which is specifically for a strip footing. And then, based on the I value, we can find the final. We can find either the initial or final settlement. So, with a strip footing, we can define a strip footing. So this is in section. This is the strip footing on the profile of soil. Now in plan, a strip footing has, say, a dimension of 10 meters, which is we got here, and relative to this dimension is pretty much infinity, so it goes on forever. So in other words, this dimension is a lot longer than that dimension. Practically speaking, this could be something like an embankment, where this dimension is much smaller than that dimension. So for a strip footing, like we did with a rectangle in a couple series ago, we had to split the rectangle up into corners. The strip footing is sort of similar. We have to split it up into not corners anymore, but edges. So we're going to do an example. We want to find the, let's do the final first, the final settlement under the center line, under the center line of our embankment. So in other words, we want to find the settlement through this center line, which is the center line of the embankment. So we have to split our embankment into two, and every shape we use has to have an edge, so no longer a corner but an edge on that point, on that line we're interested in. So if it's perfectly down the middle, we're going to have to split our shape up like that, where B is now equal to 5 meters. So B is that length and that length. So we're going to do this case for B equals 5. We're going to find the final settlement, and then we're just going to multiply it by 2, because there's two lots of these, because every edge has to be on the edge we're looking at. So we split it up into this shape and split it up into this shape, which both have edges there, and because they're the exact same dimensions, we're just going to find it for 1 and then multiply by 2. So for a final settlement under a center line. Now let's say we're given the properties E dash equals 5 MPa and V dash equals 0.3. Now because we're doing a final settlement, that straight away tells us that we are looking at the drained properties, which is the V dash and the E dash. So if we were to work this out, the first thing we need to find is B on H or H on B. Just like the circle case, we've got different spectrums of values. So in our case, H is 20 meters, B is now 5 meters, not 10 meters. We've split it up like this so that we have an edge on the center line, which means that we would find B on H, which would be 5 on 20, which is 0.25. We know that V dash equals 0.3. So we would use these two pieces of information to come to our graph here. So we have B on H is 0.25. So that is B on H, 0.25 is that value there. And we're going up to V dash equals 0.3. So we're given all these V values on the side here. Once again, I just did this in Photoshop and drew it, so it's pretty rough. Your values might be different. So V equals 0.3 would be between 0.2 and 0.1. So it would be around there, say. So if we were to come up to a point there and come across, we would get an I value of around 0.7. So our I will equal 0.7. And we need to know the equation for settlement. So settlement equals pH on pi E outside of I, where H is layer thickness, P is the stress applied or the pressure applied, pi is pi, E is the modulus of elasticity, mod E and I is from the graph. So let's say in our case we have a stress of 100 kPa. So then we can go and work this out. The settlement will equal the stress, so 100 kPa, by H, which is the layer thickness of 20 meters, divided by pi. times by E. Now E for our case is 5 MPa or 5,000 kPa, keeping our units consistent because we're looking at final settlement where it's drained, times by I, which we found to be 0.7. And now this is all multiplied by 2 because we split our embankment up into 2 rectangles so that they both had an edge on the point we're looking at, which is the center line. And because they're the exact same, we're just going to multiply by 2. So this part of the settlement equation would be just due to this section, but because we've got 2 of them which are the exact same, we just multiply by 2. If this was somewhere else, we couldn't just do this. We'd have to work out the settlements for the left hand side and the right hand side separately if this wasn't symmetrical. We're going to see that in a couple of videos time. Anyway, so we would come and work this out. So 100 by 20 divided by pi by 5,000 by 0.7 by 2, we would get 0.1783 meters, which is the same as 178.3 millimeters. Okay, so that's how you find the final settlement. If we were now to do the initial settlement, so initial settlement, as soon as we see the word initial, we know that means undrained conditions. So we're looking at the undrained, which is E subscript U and V subscript U. We know always that VU is 0.5, but we're going to have to go and find EU. We know EU is equal to 3E dash on top of 2 outside of 1 plus V dash. So 3 outside of 5,000 on top of 2 outside of 1 plus 0.03. Those values are just given to us in the question. We would then work this value out to be 5769 kPa. Then we would use our graph again. B on H is still the same, that does not change. Our B on H value was 0.25, so that's still the same. But our V dash value, our V value is now 0.5. So we're going to go, I'm going to do this in blue to show the difference. So we're going from 0.25 to 0.5 this time, so that's that curve there, 0.5. We would shoot across, and we get a value of about 0.38, call it. So I equals 0.38. We would now find the settlement. So we know settlement is pH on top of pi E outside of I. Our pressure is still the same, it's 100 kPa, times by the height, which also has not changed, that's still 20 meters, divided by pi times E. E has now changed to 5769, and this is all times by I. And once again, this is all multiplied by 2 because we're looking at the center line and we split our shape up into 2. So that's still multiplied by 2. If we were to work this out, so 100 by 20 divided by pi times 5769 by 0.38 by 2, we get 0.08387 meters, which is the same as 83.87 millimeters, which we would just want to check. So we got a final settlement of 178.3 and 83.87. So intuitively that makes sense. So once again, it's very similar to the circle example, except the only difference is we have to split up our strip footing into, so we were looking at the center line, which means that that center line is the edge we're concerned about. So we have to split up our embankment such that every shape has an edge on the embankment. This example was nice because we split it in half, so we just found the 1 and then multiplied it by 2. To find the final settlement, we had to use V dash and E dash for the drained values, and for the initial settlement, we used the undrained out values of EU and VU, and the process is otherwise the exact same. Hope that helps, guys.